Hello, my name is Darren Thomas and I am the Director of Educational Research Techniques. In this video, we're going to be taking a look at how to multiply monomials. So let's go ahead and get started. So a monomial, well, you guys saw how it was spelled. Mono, of course, means monomial. I guess that's how you spell it. Yeah, monomial. So mono, of course, as you could probably already tell, means one. And mio kind of means like term or name. So a monomial is like when you have one term, one name. And so what we're going to do here is we're going to multiply monomials. But let me start by giving an example here. So let's say I have 4x squared. This is an example of a monomial. And then I multiply it by 3x to the third power. So I have two monomials here, 4x squared and 3x cubed basically. That's my monomial. And so to multiply this is really not that complicated. You simply just combine like terms, if you will. So if I had to do this, 4 times 3, so you got 4 times 3. And then to wrap it up, you essentially have times x to the second power times x to the third power. So again, this is not that deep. 4 times 3, of course, is going to be 12. You can figure that out. And you know from prior videos or from your background experience in dealing with algebra that when you multiply numbers that have the same base or even different bases that are raised to whatever powers, you just add the powers together. So in other words, x times x, or x squared times x to the cube, is going to be the same as saying 2 plus 3, if you will. And so you end up with x to the 5. The base does not change because they're the same base. That's what's happening there. So our final answer is 12x to the 5th power. Not that complicated. Let's do another one. This one's a little bit different. And so in this particular example, we still have a monomial, two monomials. We have 5 over 6, and then we have x to the y square. That's still a monomial, even though there's more variables. It's still a monomial because it's just one term when you multiply it all across like that. And then we have 6x to the 3 y. Okay, so let's go ahead and go through this process again. So the first thing we're going to do is, of course, we're going to deal with like terms. So the constants here is going to be 5 over 6 times 6 over 1. I'm just putting the 1 to make it consistent. Sometimes I know people get confused by that. And then we want to deal with the next terms that are similar here. So times x to the 3. And again, to be consistent, just so you can understand where the answer is coming from, yes, it's x, but we're going to make it x to the first power because that's what it literally is. And that'll make more sense when we start doing the addition. And then times y to the second. All right, so 5 over 6 times 6 over 1 is going to be 30 over 1, which we know is going to reduce to, 30 over 6, excuse me. 30 over 6, 5 times 6 is 30, 6 times 1 is 6, like so. And then you have x to the first power times x to the third power. We add the exponents and we get x to the 4, and then y is all alone. He just becomes this, y. I forgot something, excuse me. Let me fix that real quick. I forgot this term right here. I'm sorry, I forgot to deal with this y right here. So we got to add that. So make that a square and then just add the y here. Excuse me. So again, there's no 1 here, but I'm going to add it just to be consistent. So y squared times y to the first. That's going to be, 2 plus 1 is going to be y to the third power, like so. And now when we simplify this, because we have to simplify this guy right here, 30 over 6 is going to become 5. And then we have x to the 4th. Make that nice and clear. And then we have y to the 3rd, like so. And so you can see that's what our answer is going to be. 5, x to the 4th, y to the 3rd. That's how that works out. And so you can see the beauty of how this works. We're going to do one last example, make sure things are nice and clear so that there's no confusion. So this time we have 5 x to the fourth. Then we have 7 times x to the 3 times y, like so. Again, you guys probably know the steps by now. We're going to first deal with this guy right here. So 5 times 7. I'm sure you know what the answer is to that. And then right here we have x to the 4. Oh, let me put a little dot here. Times x to the third. And then it looks like this time we only have the 1y times y. So 5 times 7 is going to be 35. X to the 4 times x to the 7. You add together the exponents. You're going to get x to the 4, x to the 4 power times x to the third power. Of course, you're going to add the exponents to get x to the 7th power. Like so. And then the y is just by himself here all alone. And that's how you do it. So you can see that dealing with monomials is really not that complicated. What you need to make sure you have a mastery of is how to deal with the exponents if they are present. And of course, you have to have a background knowledge of how to deal with fractions if they are present. And of course, you know, dealing with the constants should not be that much of a problem either, because that's just basic multiplication. So in this video, this is what we did. We learned how to address and to deal with multiplying monomials. Mono meaning one, and the back half of that word, the suffix of your meals, meaning probably term or name. And so the process is not that complicated, but oh, trust me, there are ways you can make this much more difficult, as you will see in other algebra textbooks, if you will. So my name is Darren Thomas. I am the Director of Educational Research Techniques. Thank you. Take care.